Unfortunately for us, not having one of these, a PhD, or having one of these, an MD, didn't stop JD Vance from trying to tell the rest of us what science actually is. Here's what he said.
Anyway, is sometimes there's this attack where people say, well, you know, this or that conclusion is not supported by the science, or this or that conclusion is a conspiracy theory. And science, as practiced in its best form, is that if you disagree with it, then you ought to criticize it, and you ought to argue it against it, but you can't shut down the debate.
The thing is, science is not about debate in the sense of you give an opinion and I give an opinion and both of our opinions are valid. That's not what science is. Science is about collecting data and evidence and having well-designed studies. So you can criticize the design of a study, which is exactly what many of us did when RFK Jr. said that Tylenol causes autism. You may recall at that time we discussed one of the key studies that he was pointing to, which was a review of a number of studies, only 7 of which looked at Tylenol and autism, by the way. And the studies that were included were what we call observational. And that is why so many times you heard people saying that these data showed a correlation, but not a causation. That's how you argue in science. You talk about the design of a study and what kinds of inferences can validly be made from a particular type of data. Science in its best form, to use his words, is when the research question, the research methods, the data analyses, and the interpretations are all in alignment. So if you want to answer a causal question, does A cause B, then you use a causal design, which would either be a randomized controlled trial or a quasi-experimental design. If the research question is more descriptive, like what is the average age at which people are getting diagnosed with colon cancer, then you don't need an experimental design. You just need a large enough data set to be able to make conclusions about the population of interest. That means you can't take data from 5 people and say that represents the entire country, right? This is one of the essential functions of what's called peer review. This is why scientists read each other's work to say, hey, I don't think you can actually make that inference here. Or can you look at this other question? Have you analyzed your data this other way? That's ideally what should be happening in the peer review part of the publication process. But of course, JD Vance has no idea about any of that because he's not a scientist.